This is ECAA 2021, Section 1, Question 11. So we have a curve with the equation y equals x squared minus 4x plus 5, and we're told it meets the line y equals 2x plus c at two different points with x coordinates p and q respectively. We're told that if we take q and minus p, we get an answer of 8, and we have to work out what is the value of c. So where should we start in this question? Well, we know we have two lines that are intersecting with each other, and to sort of work out what the intersect of those are to find the x coordinates, we have to make them equal to each other. So if we do that, we get this: x squared minus 4x plus 5 equals 2x plus c, and then we can simplify this down, make this equal to 0 to give us a nice quadratic to solve by taking away the 2x and the c to get x squared minus 6x plus 5 minus c, and that equals to 0. So now if we were going to solve this for x, we could just factorise it, and the 2x would be our two coordinates p and q. Now there's too many variables in this, so we can't really do it by factorising, but we can do it another way. We know our x values already, they're p and q. And so if we were to factorise this into sort of a nice equation, we know that our brackets must be x minus q to give us an answer of x equals q, and x minus p. So we can kind of work backwards and figure out what the quadratic equation would be in terms of x, q and p, and then we can compare it to this one. So to find that, all we need to do is times these two brackets together, and that would give us an answer of x squared minus qx minus px plus qp, and that equals 0. So both of these quadratic equations are equivalent to each other. So what can we learn from that? Well, these terms, minus 6x and the minus qx minus px, must be equal to each other, as well as the unit terms. So 5 minus c must be equal to plus qp. And finding out what these are will help us to work out what c is. So let's start with our red highlighted ones there. We know that minus 6 must be equal to minus q minus p. Those are both our x coefficients there. And we know that q minus p equals 8. And we can use these as simultaneous equations to work out what q and p is. So I'm going to take away the top equation from the bottom equation, and we get 2q equals 14. So if we divide them both by 2, you get q equals 7. And now we can substitute our q equals 7 into our equation, so let's use this one here. We get 7 take away p is 8, so p must equal minus 1. So now we have q and p, we can finally work out what c is using our green highlighted terms here. So 5 minus c must be equal to q times p. We know that q times p is 7 times minus 1, or minus 7, so 5 minus c equals minus 7. And we can move our c across to that side to get 5 equals c minus 7, and then plus our 7 back on. So c is 12, and our final answer is F.